Hello everybody. In this video, we are going to be using our Excel files in order to help us answer normal distribution problems. So let's look at our guide. So it says the amount of time to complete a physical activity in a PE class is approximately normally distributed with a mean of 36.2 seconds and a standard deviation of 5.4. Okay, so let's go ahead and plug in here our mean of 36.2 and our standard deviation of 5.4. And right now we're just dealing with sample sizes of 1. Okay, so we have our distribution here. It's centered on our mean. It's got the right standard deviation. And here we have a probability statement. So we have what is the probability that a randomly chosen student is going to complete the activity in less than 31 seconds. Great. Okay, so we can come over here. We can use our value version of this because we've been given values instead of probabilities. So here we're going to put our left cut as something very, very small because we are trying to go less than. Technically, we could put in negative like infinity, but you can just put a small number relative to the values here. 0 is a lot of standard deviations away. As long as you have a number that's like at least -5 on the z value, like you're good for rounding values. Because remember, 3 standard deviations away has almost 99.7% of our data. So once you get out much past that, there's not a lot of data out there. The right cut here, we're going to put our 31 and we'll hit enter, and notice that it shades from 31 to the left, oh my goodness, to the left. So we see the probability of being less than 31 seconds. So we have here that the answer is 0.1678, and we see that the answer is 0.1678. How do we do this now using just our normal distribution formulas inside of Excel? Well, what we can do is the norm.dist, as stated right up here, how this value is happening. And the nice thing here is that the norm.dist always calculates the probability from a spot to the left. So this is always going to give us a less than value. So our x value here that we're going to put in is 31, comma, we put in our mean, and then the standard deviation, and then we need to say true, for it being, oopsies, for it being cumulative. So we'll do comma, give me a second, comma, and then use the word true to finish it out. And there we get our 0.16778 rounded to 4 decimal places. That's where you get the 0.1678. Okay, next, what's the probability that a randomly chosen student completes an activity in more than 39.1? Okay, so now we're going to go more than. Let's go ahead and delete these out. So we can do 39.1 is our left point, 39.1, and then I'm just going to choose a big number here, like 100 or something. Notice that I have just a big z value, and I get this shaded percent, so the shaded area under the curve is just a little under 30%, and we see that that is the correct answer. Okay, let's go ahead and do that one here. Probability that x is going to be greater than 39.1. And let's do it. We've got norm.dist of 39.1, comma, we have a mean, comma, standard deviation, comma, we'll say true, and we'll hit enter. And notice that we have a discrepancy here. The correct answer is in fact 30, but we've been getting 70%. Now remember, the norm.dist always gives the area to the left of a critical point. If we want the area to the right of a critical point, we can take the complement, which is just taking 100% minus the probability of the area to the left will give you the area to the right. So we'll go ahead and hit enter, and there we go. We got our 0.2956 that we're looking for. All right, this one says, what's the proportion of students who's between 32.3 and 41? That's easy here. We can do 32.3 and 41, and we get that it's about 57% between those 2 points. Let's write this out as a probability statement. So we'll do 32.2 is going to be, well, we want x to be greater than that, but less than 41. In order to do this, we are going to subtract off the probability of being less than 41 from the probability of being less than 32.3. So we'll do norm.dist. We will do the 32.3, comma, We have our mean of our 36 over here, standard deviation. The next one, we'll say true. Oopsies. And then we'll subtract from it norm.dist of our 41, comma, do the mean and the standard deviation and say true. Now, I have done something wrong here. Notice how I have a negative number here. Remember, probabilities can't be negative, so what did I do wrong? Oh, it looks here that I subtracted the large number from the small one, so we just need to swap out those numbers, 41, and we'll do 32.3, and there we go, our positive 0.5779 with rounding. This last one is a quantiles question, where it says 95% of students finish an activity in less than so many seconds. So we can say, okay, we want the bottom 95%. So we'll just write that here, bottom 95%. So that's going to go from 0 to 0.95. And says we go from negative infinity all the way up to about 45.08. And if we do that one here, we can say equals norm dot inverse. And we put in our probability, 0.95, comma, give it a mean and the standard deviation. And we see here that we have 45.08, which is exactly what we got up here. Excellent. And here it's rounded to 1 decimal place, but it's the same value between all of those. So that's how we can use it on question 2. Let's go ahead and look at question 3. Give me a second to just kind of clear out some values real quick, and then we will move on. Okay, so this says that company XYZ knows that the replacement times for the dishwasher it produces are normally distributed with a mean of 12 years. Okay, we've got the mean. And we've got a standard deviation of 2.2. Excellent. And we're only looking at one dishwasher at a time. It then asks, what is our distribution? Let me show you something real quick. So this is a very common way to write normal distributions in shorthand. Our first thing that we say is that our random event X is approximately normally distributed with a mean of 12 and a standard deviation of 2.2. That's all that this problem is looking for. It's a shorthand way to report normally distributed and the mean and the standard deviation. So now that we have that, we can say if a dishwasher is randomly chosen, find the probability that it will be replaced in less than 15.52. So that's a values question. We'll go back to our values. The left cut is going to be, we'll put a 0 because it's really far off to the left, and then we'll do 15.52. And we get 94%, yep, area from this critical point to the left. That shaded in looks about right from what our probability question was asking. And we'll put in the probability of X being less than 15.52 for good measures. And in order to calculate that, we'll do equals norm.dist. We have our critical point at 15.52, comma, mean of 12, standard deviation of 2.2. Make sure that you put true at the end, and we get this, yep, 94.52. Perfect. Next one, if a dishwasher is chosen randomly between two values, what's the probability? Okay, we can do that one. We can do 7.16 and 9.36. That gives us this value right here, and it looks like it's just about 10%. So let's write our probability statement again. We put our lower value in here. We say that X is going to be greater than that one, but less than 9.36. And we can do that here. Equals norm.dist. We put in the bigger one first. We learned our lesson from before. 36, comma, mean of 12, and a standard deviation of 2.2. We say true, minus norm.dist of our 7.12, comma, mean of 12, and a standard deviation of 2.2, with another true at the end. and we get our 0.1017. Oh, I think I have something written down wrong because it is, oh no, we're good. It's rounding because we've got our, oh no, we have something slightly off in what I typed in here. We have 9.36 and, oh, 7.16. There we go. Easy little mistake to make. And there we go. 0.10116, which rounded is 0.1012. All right, next one. This one's a quantiles. If the company wants to provide warranty so that only 10% of the dishwashers will be replaced before the warranty expires, what's the time length of the warranty? So the company only wants to provide 10% of warranty works. They're hoping that most of their dishwashers last longer than the warranty period. So we want to figure out where that is. So the left is going to be 0. The right is going to be 0.1. And let's get our quantiles on that one. And yep, that's shading in the bottom 10%. And it looks like that it's going to be about 9 years. Let's see what the bottom 10% is if we do it by hand, or I guess not by hand, but with the equations. Norm dot inverse. We need the probability of 0.1, comma mean of 12, and a standard deviation of 2.2, end your parentheses, and that gives us our 9.18 years. And if we round to one place, it'll be 9.2. So anyways, I hope that helps you out in being able to use our Excel in order to answer these basic normal probability scenarios.